everyone, today Emily and I will be explaining buoyant forces and Archimedes Principle. So this is the equation of Archimedes Principle. It's buoyant force equals rho times g times v. Buoyant force is the upwards force exerted on objects that are in a fluid. So it's this blue arrow right here. Rho, which looks like the P, is fluid density. Fluid density is mass per unit of volume. Here's the equation written out, and that's what they equal. G is the gravitational acceleration, 9.81 meters per second squared. V is just the fluid volume, which you can just find from measuring pure liquid or water. Archimedes was a Greek mathematician and physicist. One day, as he sat in a tub, he noticed that the water spilled out from the tub once he sat down. This helped him realize that the displaced water, the water that fell out of the tub, must have the same volume as him. Archimedes' principle states that the buoyant force of an object is equal to the weight of the fluid displaced by the object. We can see from the picture that when the object is placed in the water, there's a change. This is the displaced water, and this is what we're looking at. Here's a photo to help visualize the concept. We can see the upwards buoyant force and the downwards gravitational force. Don't forget, the density, rho, in the buoyant force equation refers to the density of the displaced fluid, not the density of the object. How does Archimedes' principle work? Well, here we have the original equation for buoyant force. In the equation, the density is multiplied by the gravitational acceleration and also multiplied by the volume. We can rearrange the original equation to be buoyant force equals density times volume times gravitational acceleration. Since density equals mass per unit of volume, it can be rewritten as mass equals density times volume, which relates to the mass of the displaced fluid. We can substitute m equals rho times volume into our original equation for buoyant force. The buoyant force is equal to mass times gravitational acceleration. mg, or mass times gravitational acceleration, also equals weight. So, the buoyant force is equal to the weight of the displaced fluid and can be rewritten as such. This is why Archimedes' principle says that the buoyant force on an object is equal to the weight of the fluid displaced by the object. Here's another picture. So when an object or substance is put into a fluid, an upwards force is created. This is a buoyant force, and it is opposite to the vector for gravity. But why do fluids exert upward forces on objects? Well, when objects are submerged in a fluid, there is a pressure difference between the bottom and the top of the object, just like in the picture. Fluid pressure increases as an object moves further into the fluid, so the pressure exerted down to the top of an object will be less than the pressure exerted upwards to the bottom of an object. The equation for water and or liquid pressure is P equals rho times G times H. Again, rho stands for the average density of water, G is the gravitational acceleration, and H is the height of the water, which is basically the depth of the fluid. The bottom of the object is deeper in the fluid than the top. So the bottom is literally just deeper than the top part. So the upwards force is greater than the downwards force, because the pressure increases as we go deeper into the fluid. Okay, I have my water in a container. Okay, I have my sad attempt of a boat. Most of it is floating. It is a very sad boat with an open back, but for the most part, you see that it's mostly floating. Oh, it's sinking. Yep. Because the water's getting into it. Well, anyways. Oh. Now we have. Oh. Look at that. This one will float. That's funny. Yeah, look, I can try to put it under. And it comes back up. But this boat all is already kind of messed up in the back. But it would float if it was made properly. And my boat is soggy. But if this was real, this boat would not sink. And if this ball was actually steel and not aluminum, it would float. I mean, sink. And now I will explain what would happen if this boat was, you know, an actual boat made of steel as well, and if this ball was a steel ball. So why do ships float? Well, as you saw in the video, my boat didn't float, but usually ships float, right? So the ship is shaped in a way that allows it to displace more water by incorporating air pockets, increasing the buoyant force that is exerted on it. This allows the buoyant force from the water to counteract the gravitational force from the earth. The ball is shaped in a way that there is not nearly as much water being displaced, resulting in much less buoyant force from the water. The gravitational force from the earth remains unchanged and overtakes the buoyant force, making the ball sink. So, from the picture you can see here that the buoyant force is a little bit longer than the gravitational force. Well, from the steel ball, the gravitational force is longer and greater than the buoyant force from the water as well. As you can see in the pictures, they're both steel. They both weigh the same, but one of them floats and one of them doesn't. Changes whether it float or not. The density, yeah. The fluid density. Here again we have the buoyant force equation, rho times g times v. The rho symbol is fluid density, which is just mass per unit of volume. But the denser a fluid is, the more buoyant force it exerts on an object. Here we have common fluids. You can see here that honey is more dense than water at 1.4 grams per centimeter squared, but olive oil is less dense than water at 0.9 grams per centimeter squared, and water is just at 1 gram per centimeter squared. So it's a nice number. Thank you for listening to me and Emily explain buoyant force and Archimedes Principle. I hope you learned or understood something. Thank you.